Rational equations. Okay, there are a variety of rational equations that you'll be asked to solve of varying difficulty. In an attempt to keep the lecture relatively small and something I feel like you could actually sit down and watch and pay attention to, I'm going to start with a more difficult equation that kind of tackles most things that you'll see. So through this one example, you should get some strategies regarding some of the easier examples that you'll see in your homework. So let's start with, let's see, I need to get the drawing tab. Okay, so let's start with negative 5u over u squared minus u minus 6 minus 4 over u minus 3 equals u over u plus 2. All right, directions will just say solve. So one thing to note is that we have a domain issue here, right? So when we're looking at possible solutions for this equation, there are certain values of u that don't make sense. For example, u can never be negative 2 because I would be dividing by 0 in this fraction. U can't be positive 3 because I would be dividing by 0 with this fraction. And if I think about what this would be factored, right, we would have u and u minus 3 plus 2. Again, we see that we have to exclude those values, negative 2 and 3 there as well. So once I do all of this algebra, I have to check my solution because u can never be negative 2 or positive 3. So if I work this all the way down and I get u equaling one of those two numbers, I need to exclude that from the solution. All right, so the object, whenever you're solving an equation that involves fractions, right? So we have numerators and denominators here. The one simple thing to do is to just multiply both sides of the equation by your least common denominator. So my least common denominator in this case is just going to be one of each factor. So if I multiply both sides of this equation by u minus 3, u plus 2, so as I distribute these two factors to each term, I will completely eliminate the denominator. So for example, with the first step, negative 5u over, I'm just going to write the denominator in factored form. So when I multiply by u minus 3, u plus 2, I can see, because really think about that as being above 1, that my denominator is going to completely cancel out. So minus 4 over u minus 3 times, again, the common denominator, u minus 3, u plus 2, equals u over u plus 2 times, again, u minus 3, u plus 2. So now as I look at each of these, I can see my u minus 3 factors cancel, my u plus 2 factors cancel, and I'm down to just negative 5u minus. When I look at the next term, the factor of u minus 3 cancels, so I'm just left with 4 times u plus 2 equals. Last term, my u plus 2 term cancels, so I'm just left with u times u minus 3. So I've taken that ugly rational equation and turned it into something that's much more reasonable to solve. So let's go ahead and clear those parentheses. So u squared minus 3u. I see that u squared term, which indicates, okay, I'm going to be solving a quadratic. A good strategy is to set this equal to 0 at this point. So I'm going to take, because I'd like to keep the u squared term positive, I'm going to go ahead and take these terms to the other side. So collecting like terms first, I have negative 9u minus 8 is equal to u squared minus 3u. And then taking both of those terms to the other side, I'll have u squared, so negative 3 plus 9 is a positive 6u, and then that would be plus 8. All right, so let's go ahead and factor this quadratic. So two numbers that multiply to 8 but add to 6. So I would say plus 4 and plus 2. So finally, u plus 4 equals 0, so u equals negative 4. U plus 2 equals 0, so u equals negative 2. Don't forget to check your answer. U cannot be negative 2. So I do need to omit negative 2 from my solution. That's extraneous. So my only solution is y equals negative 4.